Assalamu alaikum. In this tutorial, we are going to learn how to perform multiple linear regression on SPSS. Multiple linear regression is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. In order to perform multiple regression on SPS, we will go towards analyze option, correlate, and then we will click the option for bivariate variable. Now a problem is how well we can predict math achievement from a combination of 7 variables. Means our dependent variable is math achievement and our independent variables are motivation, competence, pleasure, grades in high school, father's education, mother's education, and gender. So what we are going to do, we have to take our 7 independent variables in this variable box. Grades in high school, we have competence, motivation, and pleasure. Competence, motivation, and what is left, that is the pleasure. These are the 7 independent variables. Next, options, keep exclude pairwise list. Okay, everything done. Under the table for statistics, continue, click OK. Now this table is showing the correlation between the variables. High correlation among predictor indicate it is likely that there will be a problem with the multicollinearity. Multicollinearity will always create problem with our result. What is actually multicollinearity? Multicollinearity refers to a situation in which 2 or more explanatory variables in multiple regression models are highly linearly related and that will affect our outcome. If we can just have a look over here, father's education with the mother's education, the value for these correlation, if it is less than 0.5 it is okay, but if it is greater than 0.5 then we will say that it will lead towards the problem for multicollinearity. It is the value it's showing 0.681, it's a bit larger value. Coming towards this motivation with the competence scale, the value it is 0.570, it's greater than 0.5, means we will be facing the problem with the multicollinearity. Now again back towards our table. Now we will perform our linear regression. What we are going to do, first again we will go towards analyze, regression, and then linear regression. In linear regression, as we have discussed, maths achievement is a dependent variable. Again, all the independent variables we are going to transfer it into the independent variable box like this. Grades in high school, competence, motivation, pleasure. The method, we have to select enter method, that's perfect. Statistics, estimates, model fit, perfect. We don't need to change these options. Click on model fit, descriptives, and collinearity diagnostics. That's it. We are going to click on continue after continuing. Okay, now this is the correlation matrix we had already discussed. We are going to move it further. Right, now the model summary. This model summary table, it is showing adjusted R square value. Adjusted R square value indicates what? That 0.360, it means 36% of the variance can be predicted from the independent variables. ANOVA table, it's showing the value is significant. We will move further, coming towards this coefficient value. Now its coefficient table, one of the most important is the standardized beta coefficient, which are interpreted similarly to correlation coefficients or factor weights. The t value and the significant value opposite each independent indicates whether the variable is significantly contributing to the equation for predicting mass achievement or not. If it's the significance value, it's less than 0.05, it means they are contributing significantly. Otherwise, rest, it means they are not significantly contributing. Now, in the last column, we have the collinearity statistics, which is showing what the value for tolerance and VIF. Tolerance and VIF give the same information. Tolerance is equals to 1 over VIF. If the tolerance value, if less than 1 minus R square, then there is a problem with the multicollinearity. In this case, adjusted R square value is 0.360. 1 minus 0.360, it's approximately equal to 0.6. It means what? That the values which are lower than 0.6, they are having multicollinearity problem. So this mother's education, the value is less than 0.6. Father's education, the value is less than 0.6. And what else? The competence scale, the value is less than 0.6. So these three values, it's showing what? That these three variables have the problem, will have the problem for multicollinearity. Now in our next tutorial, we are going to show how we are going to correct the problem for multicollinearity.